You know, when you look up at the night sky, you might spot Venus. It's often called Earth's twin, which is kind of funny because this is really a tale of two twins that went down two totally different roads. One became this amazing cradle for life, and the other, well, it became a scorching hot wasteland. So what happened? What was the big fork in the road? Let's dig in and see if we can solve this planetary mystery. Okay, so just look at how similar these two worlds are supposed to be. Size-wise, they're practically identical. But that's pretty much where the family resemblance ends. On Earth, we've got a comfortable average of about 15 degrees Celsius. Venus, a blistering 475 degrees. That's hot enough to melt lead. But the biggest difference, the real key to this whole puzzle, is the magnetic field. Earth has this powerful protective shield around it, and Venus has basically nothing. And that's the big question, right? How did two planets starting out so much alike end up so incredibly different? Turns out the answer is buried deep, deep inside their cores. To really get why Earth has a magnetic shield and Venus doesn't, we have to look at the recipe for making one. It's a process scientists call the planetary dynamo. And just like any good recipe, you need a few very specific ingredients all working together in just the right way. The science behind all this is called dynamo theory. All right, so here's the recipe. You ready? First, you need a molten core made of something that can conduct electricity. Think liquid iron. Got that? Good. Second, the planet needs to be spinning pretty fast. And third, and this is absolutely the key, you need convection. That's just a fancy word for the constant churning, sloshing motion inside that liquid core. You get those three things happening, and that motion gets converted into a powerful magnetic field. That's how you get a planetary. Earth, of course, checks all the boxes. We've got the liquid iron core, we spin fast enough, and that core is churning away with convection. The result? A strong, stable magnetic field that's been protecting us for something like 3.5 billion years. It's our planetary shield, and it is the reason life has a fighting chance here. Which ingredient from our dynamo recipe is Venus missing? Is it the molten core, the spin, or that all-important churning convection? Let's run down that checklist. Ingredient number 1, a molten metal core. Well, scientists are pretty sure Venus has one, just like Earth, so we'll give it a check. Ingredient 2, planetary rotation. Uh-oh, here's our first big problem. One day on Venus is 243 Earth days long. It is spinning so incredibly slowly. That is a definite fail. And number 3, internal convection. Its core isn't cooling, so it can't churn. Without that spin and churn, the dynamo engine just never gets started. No churning, no shield. Case closed. But the story isn't quite over. Yeah, it turns out Venus isn't totally defenseless against the solar wind. It has a kind of shield, but it's not one it makes for itself. It's a shield of borrowed power. And as you're about to see, it's a pretty flimsy defense. What it has is called an induced magnetosphere. And here's basically how that works. The solar wind is constantly flowing from the sun, and it carries the sun's magnetic field along for the ride. When that field slams into Venus's upper atmosphere, it charges up the gas there, creating this layer of ions. And that interaction between the sun's field and Venus's atmosphere creates a weak, temporary magnetic bubble around the planet. See, unlike Earth's powerhouse dynamo that comes from within, this borrowed shield is flimsy. It's totally at the mercy of the solar wind, which can just push it around, squeeze it, and even rip it clean off. This quote from eos.org just nails it. It says, "When the magnetic field blowing past the planet changes direction, they take the part of the tail to which they are connected with them." It's literally grabbing a piece of the planet's protection and just flying away with it. This whole process is called a disconnection event. And every time one of these happens, it's not just taking a magnetic field with it. It's taking a chunk of Venus's atmosphere. The actual ions, the